When you hear the words invasive species, what's the first organism that comes to mind? For most folks, it's a land-dwelling animal like the mountain pine beetles killing trees and forests across the western US, feral hogs in Texas, or perhaps even the terrifying 10-foot-long Burmese pythons in Florida. But what if I told you that there are dozens of aquatic invasive species inflicting damage upon freshwater ecosystems in your backyard? Did you know that in the United States, invasive species are now the second leading cause of native species extinction? And their annual damage costs have been estimated at $120 billion. That's billion with a B. One of these species that's generating concern is the gizzard shad, and they're the subject of my dissertation research. The gizzard shad is a freshwater fish related to herrings and anchovies, and the species has a few unique characteristics that make them particularly skilled invaders. They're fast-growing, highly prolific, and can quickly become overabundant in small lakes, since females can release tens of thousands of eggs over the course of a single spawning season. The species' range has expanded in recent years due to intentional and unintentional introductions, flooding, and their knack for colonizing and thriving in new habitats. Fisheries biologists around the country are interested in applying a chemical called rotenone, a pesticide, to kill off this invasive species in bodies of water where they're causing problems. Because it's thought that shad removal could improve sport fish growth rates to make anglers happy while also addressing water quality issues. For the past 4 years, I've been collaborating with the Kansas Department of Wildlife, Parks, and Tourism to study gizzard shad in 12 small artificial lakes. At the start of our study, 8 had gizzard shad populations and 4 did not. Oh yeah, right, okay. 4 lakes received rotenone treatment to remove shad in December of 2018, and the other 8 were intended to serve as control lakes without gizzard shad. With and without gizzard shad. We sampled lakes during the growing season in June, August, and October from 2017 through 2020, so that's 2 years before and 2 years after rotenone application, to assess ecosystem responses over time. We used boats with generators to apply electrical current to the water to be able to capture and then collect data on the entire fish community. We measured fish lengths and weights, we examined their diets by cutting out their stomachs and looking at them under a microscope, and aged the fish using their ear bones, like rings in a tree. Our goal was to figure out how the ecosystem functions and what the role gizzard shad played within them. Let's pretend a small lake food web is a Jenga tower, and each block represents different species at different levels of the food chain. When we applied rotenone to remove gizzard shad, we pulled out a Jenga block from the tower and studied whether the ecosystem teetered toward collapse or if the tower didn't budge. Now, serendipitously, in the middle of our experiment, we actually had 2 of our control lakes without gizzard shad that experienced accidental shad introductions. We don't know if they were caused by flooding or by anglers dumping live bait into the lakes, but then also 2 of the 4 shad removals were unsuccessful, and the species came back with a vengeance in one lake, proving just how difficult the species is to control. We're still analyzing our data, but it appears that gizzard shad have less of an impact on sport fish and water quality than we predicted, and rotenone applications might be more of a band-aid than a silver bullet for shad control. Invasive aquatic species like gizzard shad present growing threats to water quality, and the costs to manage them are skyrocketing. Understanding whether short-term solutions like chemical eradications are effective could help us conserve taxpayer dollars, mitigate water quality issues, and protect native fishes from extinction. Thank you. Fuck that.